Arkadaşlar merhaba. Sesimi duyuyor musunuz ve ekranı görebiliyor musunuz acaba? Tamam, peki. Teşekkürler. Okay, then let us start. I hope you are fine, okay, and you are happy at your home. Before starting our problem session today, I want to ask if you have any problem with your last homework, okay? And this week I received some emails about graphical user interface and mock-up screens. Actually, these screens, these mock-ups, graphical user interfaces, are not included in this homework, okay? We are going to assign those screens as another independent homework, okay? The next homework will be graphical user interfaces, mock-up screens of your project, of your product. Okay? And these are the titles included in your homework. Introduction, you know, similar with your previous homework requirement specification document, and you need to write your design considerations. Okay, I sent you an example, and maybe the most important part of this homework is system design. Okay, you need to draw your architectural system design, including subcomponents. Okay, and then you need to draw your class diagrams. And I know that actually you are familiar with class diagrams with your some previous courses, lectures. Okay, but still, if you have any problem, just let me know. Okay. Anything you wanna ask related to this homework? Yes. Any question? Any feedback? Uh, One of your friends is asking that I received two questions. Okay, let me answer those questions. One question is asking that if you are expected to draw many detailed class diagrams or not. Okay, and actually this depends on your projects, your products requirements. Okay, and depends on your system. If you have several modules, subcomponents, okay, and if you have more requirements, then of course you should have more than one class diagram. Okay, actually this is a term homework of this lecture, of this course. Okay, and you don't need to have just one class diagram. Okay, so you need to have more detail, including maybe three or four classes, including their corresponding fields, methods. Okay, and you need to specify the appropriate relationships between these class. Okay, and just know only one single class. Okay, or no two classes in your diagram. Maybe you can have just one class diagram, okay, just one class diagram, but in every case, you should have more than two or three classes in your class diagram, okay? And you should specify fields, methods, their types, I mean, public, private, okay? And you should specify the relationships between diagrams. And I know that you have some experience before this lecture, okay, with your previous courses, such as object-oriented design, okay. So I don't think that this drawing class diagram for this term project will be harder, will be hard, problematic for you, okay? Okay, Nur Deniz, uh, did you receive answer? If you still any question about this topic, you can ask. Okay, and I received one more question. Yes, Chala is asking me to send some examples. Okay, I actually sent an example to Google Classroom this week. Didn't you receive? I sent an example to Google Classroom. Did you check it? Chala, please check it from your Google Classroom. Okay. Okay, thank you. And any other questions related to your last homework before starting our problem session? No question? Okay, then let us start our problem session. Okay, and do you remember this document I shared with Google Classroom last week? Okay, please open this document. Please open this document. We started solving these questions last week, and we will continue the remaining questions. Okay, then we will start some other questions. Okay, first we will finish these questions. Okay, please open this document. I'm giving you a few seconds. Please open this document. I shared it with you last week on Google Classroom. Okay, did you open the document? Now please read the question number 5, okay? The question: in software system development, a key issue is to select a development method that should keep the development cost as low as possible. Are critical software systems an exception to that? Why not? Okay, I'm giving you I'm giving you 2 minutes, okay, to take your own notes to write your own answer into this document or your paper notebook, wherever you want, okay? You have 2 minutes. Okay, are you done? And then let us start discussing this question, okay? And can you see this answers document? Okay, I'm sharing this answers document, okay? And the results of failure of critical software system are typically disastrous, okay? Disastrous in Turkish means felaket, çok kötü. Hence, in selecting methods that are employed in developing critical systems, the cost effectiveness of the development method is not the main concern. Okay, main concern means ana nokta bu değil, ana düşüncemiz, öncelikli düşüncemiz bu değil. Okay, we can say that yes, critical systems. Let us read the sentence again. In software system development, a key issue is to select a development method that should keep the development cost as low as possible. But we need to say that critical systems are exception to that. Okay, why critical systems need to be an exception to that sentence, okay? Because selecting methods that are employed in developing critical systems, the cost effectiveness of the development method is not the main concern, okay? And did you understand this sentence? Did you understand this explanation? So our concern is not the cost effectiveness, okay? Our concern should be something like maybe about safety, reliability, okay? The cost effectiveness is not our first number one concern in critical systems, okay? Because the results of the failure of critical software systems are typically disasters, okay, for human beings' life. I guess you are done. You take your necessary notes, okay? Then let us continue with the next question, okay? The sixth question. The sixth question. And please read the question. And again, you have 2 minutes to take your own notes before starting discussing all together. Okay, are you done? Then let us start. Uh, in the question, consider the software systems below. Okay, the fourth one will be homework to you. Autonomous unmanned underwater vehicle, wheelchair controller, material handling system software. Okay. How would you classify these systems in terms of their criticality? Okay. And remember the types of critical systems, mission critical systems, safety critical system. Remember these kinds of critical systems from your slides. Okay. Autonomous unmanned underwater vehicle control software and software for a material handling system are both mission critical software systems, since its failure will result in the failure of some goal-directed activity. Okay, so the main focus here is we have some goal-directed activity in autonomous unmanned underwater vehicle system and material handling software system. Okay, we have some specific goals in these kinds of systems. So we can say that we can classify these systems as mission critical systems. Okay. How about the second system in the given in the question? Wheelchair controller. Okay, wheelchair controller software is a safety critical system, since its failure may result in loss of life or injury. Okay, why? Because human beings use these systems. Okay, actually, a human sits over a wheelchair system. Okay, did you understand? Any question? Anything you want to ask? And the fourth system, antivirus in your PC. I'm leaving this one as homework to you. Okay, classify this system whether it's safety critical system, mission critical system, or business critical system. Okay, this is a small homework for you. Okay, then let us continue with the following question. Okay, this is the following question number 8. Okay, and please read the question and try to give your own solution. You have 5 minutes. Okay, this is a long question. You have 5 minutes. Everybody has a document? Everybody has this document? Okay, okay. And let's start reading the question. Consider two critical software systems, an insulin pump and an artificial pacemaker. Okay, and what is artificial pacemaker? Yapay kalp pili. Okay, in Turkish. And you will remember that you have studied software control insulin pump as an example in your class discussions of critical systems. Okay, you have the system in your slides. Okay, and the second system is an artificial pacemaker. Let me repeat in Turkish, yapay kalp pili. Let us see its official definition, okay, as a medical device that uses electrical impulses delivered by electrodes contacting the heart muscles to regulate the beating of the heart, okay? And the primary purpose of a pacemaker is to maintain an adequate. Okay, adequate means appropriate enough, okay, heart rate, either because the heart's natural pacemaker is not fast enough or there is a block in the heart electrical conduction system, okay? And focusing on the formal definitions of safety and reliability, and taking into consideration the following two remarks about reliability and safety, discuss how the two critical systems above relate to the two system properties, safety and reliability. So did you understand the question? We are expected to discuss safety and reliability properties of these two systems, okay? And let us remember the definitions, the properties of reliability and safety. Reliability is concerned with the conformance to a given specification and delivery of service. Okay. And safety is concerned with ensuring system cannot cause damage irrespective of whether or not it conforms to its specifications. So the last part of the sentence is actually important. And be careful that it says that safety is concerned with ensuring system, okay, cannot cause damage irrespective, okay, of whether or not it conforms to its specification, okay. And so let us continue. Software control insulin pump system. Uh, Delivery of the correct amount of insulin is critical here. Okay, delivery of the correct amount of insulin is critical here. Delivery of an overdose erroneously computed is especially critical since the corresponding hazard, severity, and estimated risk is high, and it is intolerable since it may be fatal. Okay, did you understand? So the amount of dose in such a system, insulin pump system, is actually very, very important. Okay, the amount of dose, and if there's a risk that giving a overdose, then this will be fatal. Okay, so this is intolerable. Okay. And how about artificial pacemaker? As defined above, it regulates and maintains a sufficient heart rate whenever the heart's natural pacemaker is not fast enough, or there is a block in the heart's electrical conduction system, which are both fatal cases. That is, artificial pacemakers failing to function cannot be afforded. Okay, afforded means in Turkish tolere etmek. So here this says tolere edilemez. Okay, it must keep on delivering service as specified, even it functions incorrectly. Okay, please be careful here. Pay attention on the sentence. It should not stop functioning, okay, because it is the heart rate of the of that human, okay. Artificial pacemaker should continue, but this insulin pump system should stop. Okay, let me first let me clean the board, please. Okay. Okay. And while insulin pump, the above discussion implies that the insulin pump must stop, okay, in such a case to avoid overdose risk, okay, and this perfectly matches with the definition of safety, okay. Consequently, the insulin pump must stop to function so a fatal risk can be avoided, which matches with the definition of reliability. Okay, but what did we say about artificial pacemaker? Artificial pacemaker should continue functioning even it functions incorrectly. Okay, artificial pacemaker system must continue working. Okay, so I am leaving the last part of this question, okay, to you as a small homework, a small exercise from your final exam, okay, and discuss reliability and safety of the system. Actually, we started answering this part. We said that artificial pacemaker system must continue working. Okay, then you need to continue. You need to fill the last part of the answer. Okay, discuss reliability and safety of this artificial pacemaker system. Okay, okay. Did you understand? Okay, then let us continue. Let us continue with the following questions. I actually need a few seconds. Okay, I am sending you documents to Google Classroom. Please check your Google Classroom. Okay, in a minute you can receive the documents. In a minute, please. Okay. Okay. Please check the Google Classroom. Please check the Google Classroom and get the documents. Okay, thank you, Meta. Actually, actually, before starting design questions, maybe to the end of this hour, we can continue with previous midterm exam questions related to class diagram. Okay, I shared this document. Can you see it now? I guess you can see the document, okay? And I also sharing it with Google Classroom, okay? Uh, in a few seconds, okay, in a few seconds. Okay, please get the file on Google Classroom. Get the file, please. Get the file and open it, please. Okay, this is a previous midterm exam question. It says convert the following Java code with equivalent class diagram. Did you heard about reverse engineering? Anything did you hear about reverse engineering? Write relevant multiplicity values. Be careful on the relationship types between classes. Okay, and in the exam, the question giving the Java code. Okay, and it is asking the corresponding class diagram. Okay. Please close your microphones. Please close your microphones. Okay, thank you. And let us check the diagrams. Okay, and we have which diagram in this Java code? We have class name, we have class number, we have class school, we have class department, we have class student, we have class course, we have class instructor. Okay, and we should draw these classes, including their corresponding fields and methods. Okay, and these are the fields: name, address, phone, and we are also giving the types, and we are also giving the methods here. Okay, so we should write these things in the class. Okay, and we need to write we need to do the same thing for all classes here. Okay, and this is the first thing we need to do in this conversion. And after that, we need to specify the relationships between classes. Okay, actually, the relationships with their related cardinality values are given in the Java code. Okay, and between we are restricted has one to many members students compose one to many has one to many departments. Okay, this this relationship is between which classes? Please check it. This relationship is between which classes? Please check it. Okay, this relationship between school and between class students, as it says here. Okay, let me annotate it. Okay, let's let me draw it here. Okay, it says, so this relationship between school and class student as it specifies. The name of the relationship is member, okay, here, member, and it says has a relationship here, okay, has a relationship here. It is shown like that as you can remember from your object-oriented class, okay? And we have one to many, okay? Here we have one and we have many, okay? And how about the other ones? Let me check those ones. Okay. How about student one? Student has a relationship between course. Okay. Here, can you see? We have a relationship between course and students, and name of the relationship is what? Name of the relationship is attends. Here, okay. And name of the relationship is attends. Okay. And we have many to relationship. Okay. And we have this relationship between students and course. Okay, and in a similar way, please check the other relationships between remaining classes. Okay, check the relationship between, for example, instructor, class instructor, and class course. Okay, check the relationship between class department and class instructor, class departments between class course, between class departments and class instructor. Okay, please check the relationships. You can create your class diagrams, okay, using some tools, okay. You give just the code here, as you can see in this example, and by using this tool, you can create the class diagram. The reverse also is possible, okay, using some specific tools and giving the diagrams, you can create the corresponding code, okay. Please search about these tools and make necessary small exercises, okay. And now I am taking attendance. Please write your name and surname into the chat box, okay? Please write your name and surname into the chat box. Okay. You have 2 minutes. After that, we are going to give 10 minutes break. Please write your name and surname into the chat box. I'm taking the attendance.